So let's work through a quick example for a factorial ANOVA, and with this we'll work through completing an ANOVA table. So here's a study to where we've got two independent variables. One is humidity and the other is temperature in Fahrenheit. So you'll see there's two levels for the humidity one, and there's three levels for the temperature. And so we've got 60 participants. They're randomly assigned equally to one of these rooms in essence, and they're taking a problem-solving test, and this is the average score for each of the different groups. So you'll see we've got 60 total subjects evenly divided into each one of these cells. And so here then you can see there's a difference. At 70 degrees they scored 80 on average. At 80 degrees they scored 75. And at 90 degrees they scored 70, and over here we've got 80 and 70 as a difference in terms of the humidity. But then also we're interested in the interaction, that we'd want to graph that interaction. So if we go and graph that interaction, we'll make it easier, 50, 60, 70, 80. So this is how they did on the problem solving test over here on the y-axis, and on the x-axis we have the temperature in Fahrenheit, and then we've got the humidity over here as a square and as a circle. And so for this first set here, as we look through, we've got 80s all across for when it's in 30% humidity, and so 30% humidity is the square. Okay, and then you'll see it's different for when we have the 70% humidity, and so it was 80. They score average 80 for 70% humidity in 70 degrees. In 80 degrees they average 70, and then 60 for when it was 90 degrees and 70% humidity in the room. And so you'll see here we do have an interaction. The lines aren't parallel with one another, and in essence what it's saying here is, hey, it's not just the heat, it's the humidity. It's you combine the temperature together with the humidity. That's what makes the situation unbearable. So let's go and look through how we would complete an ANOVA table for a factorial ANOVA. And so in this case, the first thing that we do is we look at the degrees of freedom column. And so this is based on this study that we have up here. So our information for degrees of freedom are up there. So for the between treatments, what we have is we've got 6 cells total. So 6 minus 1 gives us 5. So that's the degrees of freedom for the between treatments. For the temperature, we've got 3, as we see across here. So 3 minus 1 gives us 2. In humidity, remember we had just 30% and 70%, so 2 minus 1 is 1. And then the interaction, how do we get the degrees of freedom for the interaction? All we do is multiply this degree of freedom times this one, and we get 2 for that. Okay, so we're just multiplying the degrees of freedom for A times the degrees of freedom for B, and then we get the interaction degrees of freedom. Our total degrees of freedom, well, we have 60 subjects altogether, so 60 minus 1 is 59. Then we've got a couple different ways where we could get this within treatments, degrees of freedom. One would just be 59 minus 5 would give us 54. The other way to think about it, too, is within each cell, the degrees of freedom is 10 minus 1 is 9. 9 times 6 is 54 as well. That's the other way to think of how we would get that degrees of freedom for that. So once we have the degrees of freedom, we can start solving for sum of squares for each, the rest of the missing information. So for here, what divided by 2 would give me 8, 16 would. For here we've got an F ratio that we can work with. We'll have to hold off on that. For this one we say what divided by 2 would give me 18, 36 would. And then here 108 divided by 54, that's 2. Okay. And so for here, then we look here, we know that this F ratio is 3. So what divided by 2 would give me 3, 6 would. And then I can work backwards here. What divided by 1 would give me 6, 6 would. And then the rest of these, this F ratio here, 8 divided by 2 gives me 4. 18 divided by 2 gives me 9. Okay, so then we completed this incomplete factorial ANOVA table.